Hello students, I am Dr. Manju Gupta. Today I am going to explain chemical reactions of amines, part 1. This is the topic of 5th unit of paper 3, organic chemistry. The first chemical reactions of amines is reactions with alkyl halide. All amines react with alkyl halide to form quaternary ammonium salt as final product. Quaternary ammonium salt can be formed by the reaction of amine with alkyl halide. For example, reaction of ethylamine. Reaction of ethylamine with any alkyl halide. Suppose we are taking ethyl iodide. Reaction of ethylamine with ethyl iodide. In the first step of the reaction, there is the elimination of one molecule of Hi, hydrogen from NH2 group, and iodide, and formation of C2H5 and C2H5H, diethylamine. Diethylamine. Again, diethylamine reacts with other molecule of ethyl iodide and form triethylamine, C2H5 and C2H5, C2H5, triethylamine. This triethylamine, when again reacts with Hi, sorry, not with Hi, with C2H5Hi, it forms quaternary ammonium salt. Tetraethyl ammonium iodide. Nitrogen becomes positively charged and iodide remains as the counter ion, negatively charged counter ion. So this is tetraethyl ammonium iodide. In this way, the quaternary ammonium salt or quaternary ammonium iodide is formed. Any quaternary ammonium salt on treatment with silver hydroxide, this quaternary ammonium salt is converted into quaternary ammonium hydroxide. And when this quaternary ammonium hydroxide subjected to heating, upon heating, it gives tertiary amine and alcohol or alkene. Here you can see this is quaternary ammonium hydroxide formed by the reaction of salt, quaternary ammonium salt and silver hydroxide. When it is heated, there is the elimination of water molecule or formation of alkene and tertiary amine. This step of the reaction, this step is known as Hofmann elimination reaction. Not the whole reaction, only the last step is known as Hofmann elimination. So this was the first reaction, reaction of alkyl amine with alkyl halides. Second reaction is reaction with acid chlorides or acid anhydrides. First, we are taking acylation of aliphatic amines. Reaction of acylation of aliphatic amines. For this reaction, only aliphatic primary and secondary amines undergoes the acylation reaction. Upon the reaction with acid chloride, acid anhydrides or esters. In this particular reaction, hydrogen atom of amino group is substituted by acyl group. And after the substitution, and substituted amides are formed. This particular reaction is carried out in the presence of base. Base like pyridine, it must be stronger than the aliphatic amines. And the reason of the base is it removes the acid formed in the reaction, or it neutralizes the acid formed in the reaction. So first we are taking the acylation reaction or the reaction of any amine. Again, we are taking ethyl amine, reaction of ethyl amine with acid chloride. Reaction of ethyl amine with acid chloride. Acid chloride is CH3 COCl. And in this particular reaction, this hydrogen and this chloride is eliminated as HCl. Reaction is carried out in the presence of pyridine upon heating. So there is the formation of C2H5 and HCOCH3. This is N-ethyl ethanamide. Ethyl group is attached to nitrogen, so it is N-ethyl, and this is the amide group, so N-ethyl ethanamide. This is the reaction with primary amine. Same reaction is possible with acetic anhydride. This is acetyl chloride. Same reaction is possible with acetic anhydride. Reaction of ethyl amine with acetic anhydride. CH3COOCOCH3. This molecule is acetic anhydride. After the reaction of acetic anhydride, same the reaction is carried out in the presence of base like pyridine upon heating. And in this particular reaction, there is the formation of acetic acid molecule. Again, acid is formed in the reaction. And formation of the same product, C2H5 and HCOCH3 plus acetic acid. The acid formed in the reaction is neutralized by the base pyridine. In this reaction also, the HCl formed in the reaction is neutralized by the pyridine base. So that was the reaction of primary alkyl amine with acetyl chloride and acetic anhydride. Similarly, we can take the reaction of secondary amine, diethyl amine, C2H5 whole twice NH. This is secondary amine, and reaction of secondary amine with acid chloride, ClCOCH3. There is the removal of this HCl molecule and formation of C2H5 whole twice NCOCH3. N diethyl ethanamide and N-diethyl ethanamide. So these are the acylation reactions. After that, now we come to the mechanism of the reaction. First, we are taking the reaction of primary amines. Primary amine like C2H5 NH2. Reaction of alkyl amine with CH3COCl. In the first step is the attack of lone pair of electrons on the carbon. This carbon is actually electron deficient because chlorine is attached to here. So after that, in the first step, there is the formation of addition product, or the bond is formed between the nitrogen and carbon. Sorry, C2H5 N H and this carbon CH3 Cl double bond C. Since the reaction is carried out in the presence of base, In this particular step, this hydrogen is abstracted by the base. So lone pair of electron comes on the nitrogen, and simultaneously this will be the reaction. So this there will be the negative charge. After this negative charge comes here and chloride is removed. So there is the formation of C2H5 and H, C double bond O, CH3, and ethyl ethenamide plus HCl. We can write the same reaction with secondary amine. This was the reaction of primary amine. The same reaction mechanism is followed by the secondary amine. Secondary amine, suppose we are taking C2H5 and C2H5 diethyl amine, and it reacts with acetyl chloride, and in the first step it forms bond with carbon and form C2H5 and C2H5 hydrogen carbon. This bond comes to the oxygen. This oxygen becomes negatively charged, and after that here is CH3 and Cl. After that, base removes the proton. This electron pair comes here. This negative charge transfer in between the carbon and oxygen is, and chlorine is eliminated. The product will be NN diethyl ethenamide, CH3 and NHCO CH3, NN diethyl ethenamide. So the same mechanism is followed by the primary amines and the secondary amines. In the same reaction with alkyl acetyl halides or acetic anhydrides, next is the benzylation of aliphatic amines. Benzylation of aliphatic amine is carried out by the reaction of aliphatic amine with benzoyl chloride. Suppose the reaction of diethyl amine with benzoyl chloride, C6H5COCl. This is known as benzoyl chloride. This particular reaction, when for benzylation, benzoyl chloride is used, the reaction is known as Schotten-Baumann reaction. And in this particular reaction, after the reaction, this reaction is carried out in the presence of dilute sodium hydroxide. There is the removal of again one molecule of HCl and formation of an alkyl benzamide, C2H5 and HCOC6H5 and ethyl benzamide. So in this particular reaction, hydrogen of the amine group is substituted by benzoyl group. Now we come to the acylation of aromatic amines. In case of acylation of aromatic amines, primary aromatic amines and secondary aromatic amines both can undergo the acylation reaction. For example, reaction of aniline. First aromatic amine is aniline. Only in case of aliphatic amine, we are taking aromatic amine, and the reaction is same reaction with acetyl chloride. Acetyl chloride, this hydrogen is removed and form an HCOCH3. This its common name is acetanilide. Acetanilide is formed. Similarly, the reaction of aniline with acetic anhydride, CH3CO, O, CH3CO. This is acetic anhydride. Again, there is the removal of one molecule of acetic acid, CH3COOH, and formation of same NHCOCH3. So in the acylation of aromatic amine is same, only in place of aliphatic amines we are taking aromatic amines. Its name is acetanilide, or we can write N-phenylethenamide. N-phenylethenamide. Benzoylation of aromatic amines. Again, the same benzoylation reaction of aniline with C6H5COCl, benzoyl chloride, and after that there is the formation of NHCOC6H5. Benzanilide. This is known as benzanilide, or its common name is N-phenylbenzamide. Chemical name is N-phenylbenzamide, or its common or commercial name is benzanilide. So this was the second reaction. Third reaction is reaction with nitrous acid. The formula of nitrous acid is HNO2. But for the reaction of amines with nitrous acid, we are not directly taking nitrous acid. In actual, we are conducting the reaction of amines with sodium nitrite and dilute HCl. By this reaction, nitrous acid produced during the reaction, this is known as the in situ production of nitrous acid. So reaction of primary aliphatic amines with nitrous acid. Suppose primary aliphatic amine RNH2. RNH2 is reacted with HNO2, and this HNO2 is produced by sodium nitrite and HCl. Sodium nitrite and HCl. In the first step, it forms diazonium salt, RN2 plus Cl minus, and after hydrolysis, this diazonium salt is very unstable. Immediately it undergoes decomposition reaction or hydration reaction and converted into alcohol, nitrogen molecule, chloride ion, and water. We can take any example. Suppose reaction of methylamine. Reaction of methylamine with nitrous acid. This nitrous acid is produced by the reaction of sodium nitrite and HCl. First, there is the formation of methyl diazonium chloride. Methyl diazonium chloride, and this methyl diazonium chloride undergoes hydrolysis and produce methanol plus nitrogen gas and water and HCl. The nitrogen evolved in this reaction is directly related with the amount of amines taken in the reaction. So the amount of, by the study of the amount of nitrogen, we can estimate the content of amino acid and protein present in the sample. Reaction of secondary amines, secondary aliphatic amines with nitrous acid. When secondary amines react with nitrous acid, C2H5O NH, when secondary amines react with nitrous acid, they form nitrosamine, C2H5N, C2H5 double bond O plus H2. This is diethyl nitrosamine. This is yellow colored product, which is oily. Similarly, the reaction of tertiary aliphatic amine. When tertiary aliphatic amines react with nitrous acid, they form N-nitrosamine. N-nitrosamine. For example, reaction of triethylamine. C2H5 both thies, and reaction of triethylamine with nitrous acid. It forms an unstable salt, C2H5 whole thrice, C2H5 whole thrice, NH, C2H5 whole thrice, NH plus, and NO2 is present as the counter ion, which upon heating it decomposes into N-nitro-diethylamine, C2H5 whole twice, N double bond O plus ethanol. Decomposes into N-nitrosamine and alcohol. This molecule is N-nitroso diethylamine. This group is nitroso attached to the nitrogen. So this is N-nitroso and this is diethylamine. So in this way, primary amines converted into alcohol and nitrogen. Secondary amines form nitrosamine and tertiary amine form nitroso diethylamine. Reaction of primary aromatic amine. Primary aromatic amines, when react with nitrous acid in the presence of concentrated hydrochloric acid or sulfuric acid at lower temperature and between 0 to 5 degrees centigrade, they form benzene diazonium salts. This is benzene diazonium salt or chloride. This benzene diazonium salt is unstable and even at room temperature, it decomposes into phenols and nitrogen. In the same way, the secondary aromatic amines. Secondary aromatic amines react with nitrous acid. Reaction of secondary aromatic amines with nitrous acid. Suppose we are taking phenylmethylamine and HCH3. This is methylphenylamine. Reaction with HNO2. It is converted into NO CH3 plus H2O. This molecule is N-nitroso N-methyl aniline. This compound is formed. Similarly, reaction of tertiary aromatic amines. Tertiary aromatic amines like N-dimethylamine or aniline. N-dimethylamine. This is tertiary amine. When an dimethyl aniline reacts with nitrous acid, it is converted into nitrosoamine, and nitrosation reaction occurred at the para position of the tertiary amino group. This is tertiary amino group, and at para position ANO will attach. So it forms para nitroso N dimethyl aniline. So in this way, we can differentiate primary, secondary, and tertiary aromatic amines by nitrous acid reaction. Next is the reaction, carbylamine reaction. Carbylamine reaction, when primary aliphatic or aromatic amines is warmed with chloroform or alcoholic KOH, a bad smelling compound is formed, which is known as isocyanide or carbylamine. Here you can see the reaction of ethylamine. Primary aliphatic amine, when react with alcohol, it forms ethyl isocyanide. When primary aromatic amine aniline react with chloroform and KOH, it forms phenyl isocyanide. This reaction is known as carbylamine reaction because the compound forms are also known as derivative of carbylamine. Next is the reaction with carbon disulfide. This reaction is also known as Hoffman mustard oil reaction because the compound formed in the reaction has a smell of mustard oil. That's why the reaction is known as Hoffman mustard oil reaction. Again, the reaction is given by primary aliphatic amines and primary aromatic amines. When primary aliphatic amines reacts with carbon disulfide, it forms an intermediate compound, and this intermediate compound, after decomposition in the presence of mercury chloride, it forms ethyl isocyanide, and this is phenyl isocyanide. These compounds are bad smelling compounds. Phenyl isothiocyanide. So that's why this reaction is also known as Hoffman mustard oil reaction, because the product has a smell of mustard oil. Thank you. These was the reactions of general reaction of aliphatic and aromatic amine. The remaining reactions we will discuss in the next lecture.